We are Physics Group D from 19J16, and today we will be explaining the physics behind the experiment 5, the balloon experiment. We have designed an experiment to investigate how the speed of the balloon along the string varies with the volume of air inside the balloon. And I'll be explaining how we set up the experiment to ensure that the raw data is as reliable as possible. Firstly, we set up the two retort stands 4 meters away from each other to ensure that the string will be long enough for the balloon to travel and increase the time taken for the balloon to reach one end to another at all volume of air. This step is to reduce the impact of human reaction error of 0.30 seconds multiplied by 2, which is a total of 0.60 seconds. By increasing the time taken overall, the percentage error of the experiment could be lower as human reaction error will take up less percentage of time taken for a balloon to travel. Next, with string tied to the end of the retort stand, we make sure that the string is horizontal and their vertical position from the floor is the same. We hope to reduce the random error in the experiment by keeping the normal force exerted on the straw that the balloon is attached to perpendicular to the ground. This will cause the resultant force of the balloon to be vertically zero and produce only horizontal movement along the string. Thirdly, we have realized that the length of the balloon is longer than we expected in our actual experiment, and this caused the experiment to have inconsistent or failed readings. Through phone's slow motion mode, we found out that when the pump balloon is released, the shape of the balloon changes as the air leaves the balloon to generate thrust. However, the change in shape of the balloon distorts the direction of the opening of the balloon, and this caused the balloon to travel to other undesirable directions. As a result of that, the thrust generated was unable to push the balloon to another end of the string, and the time taken cannot be recorded. Even though we could not fully prevent this error, we managed to mitigate the impact of this error by cutting the two straws attached to the balloon shorter. This is because when the shape of the balloon contracts, there is enough space for the straw to close its gap and keep the balloon in horizontal shape. Lastly, when everything is ready, we use a stopwatch to time the time taken for the balloon to reach from one end of the string to the other end at different volume. This is how we obtain our data and do analysis from the data collected. And here's our video of our experiment. After repeating the experiment at 6 different volumes of air, we managed to finish raw data collection. The data shows that the time taken is inversely proportional to the volume of air inside the balloon. When volume of air increases, the time taken decreases. This phenomenon can be explained by kinetic theory of gas. In kinetic model of gases, the pressure is equal to the force exerted by the atoms hitting and rebounding from a unit area of gas container surface. When there is more volume of air inside the same balloon, the number of air particles rebounding from the wall increases and collide more frequently. Hence, they will move at more rapid speed in random motion. When the clip to close the opening of the balloon is removed, the air inside the balloon escapes at faster speed and generates a greater thrust when balloon has larger volume of air pumped inside compared to standard volume. Thus, the more pumped balloon will have higher velocity and reach the end of the string within shorter time period, just like what our data trend show. To conclude, from this experiment, we believe that the velocity of the balloon is directly proportional to the volume of air inside the balloon, where the balloon doesn't burst, and the volume of air is a factor to determine the motion of the balloon. This is the end of our physics project, and thank you for your kind attention.
3, 2, 1, go.